The directions say to determine whether the series converges or diverges. If it is convergent, find the sum. Now, the theme here is the geometric series. The summation from n equal 1 to infinity of a times r to the n minus 1 converges if the absolute value of r is less than 1 and diverges if the absolute value of r is greater than or equal to 1. So we're talking about a geometric series right here. Okay. Now, if the summation from n equal 1 to infinity of ar to the n minus 1 converges, then the sum is equal to a divided by 1 minus r. Now, with that, let's take a look at some examples. On number 1, suppose we have the summation from n equal 1 to infinity of 12 times 0.73 to the n minus 1. So if the lower limit is 1, then the exponent here needs to be n minus 1. Okay? Now, the absolute value of r is equal to 0.73, which is less than 1. So that tells me that this series converges because it's a geometric series with the absolute value of r equal to 0.73, which is less than 1. Now, to find the sum, a equals 12, okay? And r is equal to 0.73. So the summation from n equal 1 to infinity of 12 times 0.73 to the n minus 1 is equal to 12, that's a, divided by 1 minus r, so in this case is 1 minus 0.73. So this is equal to 12 over 0.27, and if I multiply the numerator and denominator by 100 and reduce, you will see that you get 400 over 9. And that's the actual sum. Let's take a look at 2. Suppose we have the summation from n equal 1 to infinity of 5 over pi to the n. Okay? Now, this one's tricky because remember that the lower limit is 1, right? And so that tells me the exponent here has to be n minus 1. So we actually have to rewrite this in referring again to 5 over pi to the n. Remember that pi to the n is equal to pi times pi to the n minus 1. And if it helps you, you can think of this as pi to the first times pi to the n minus 1. And so this is the summation from n equal 1 to infinity of 5 over pi times pi to the n minus 1, which is the summation from n equal 1 to infinity of 5 over pi times 1 over pi to the n minus 1. So remember, 5 is the same as 5 times 1. So here's the 5 over pi part, and then I'm going to rewrite 1 over pi to the n minus 1 as 1 over pi to the n minus 1 right here. Well, the absolute value of r is equal to 1 over pi, which is less than 1. So what that tells me is that the summation from n equal 1 to infinity of 5 over pi to the n converges. And that's because it's a geometric series with the absolute value of r equal to 1 over pi, which is less than 1. And so to get the sum, a equals 5 over pi and r equals 1 over pi. And so the sum ends up being 5 over pi divided by 1 minus 1 over pi. So I'm thinking a over 1 minus r, and I'm plugging in the value for a and the value for r, and I'm doing it right here. And so if I multiply the numerator and denominator by pi, I end up with 5 divided by pi minus 1. So this sum goes to 5 over pi minus 1. Okay. On number 3, suppose we have the summation from n equal 1 to infinity of negative 3 to the n minus 1 divided by 4 to the n. Well, same idea in that I have to rewrite this as the summation from n equal 1 to infinity of negative 3 to the n minus 1 divided by 4 times 4 to the n minus 1. So when you have a lower limit of 1, you need an exponent of n minus 1. But this can be written as the summation from n equal 1 to infinity of 1/4 times negative 3/4 raised to the n minus 1. The absolute value of r is equal to 3/4, which is less than 1. The series converges. It's a geometric series with the absolute value of r equal to 3/4, which is less than 1. Now, to find the sum, we know that a equals 1/4 and r equals negative 3/4. Okay? The absolute value of r is equal to 3/4, but r itself, in this case, is negative 3/4, which is totally fine. And so the summation from n equal 1 to infinity of negative 3 to the n minus 1 divided by 4 to the n is equal to 1/4 divided by 1 minus a negative 3/4. And if I simplify that, I get 1 over 7. All right, now let's take a look at number 4. Number 4 is a little tricky, and we have to be careful here. So I'm looking at 4 plus 3 plus 9/4 plus 27 over 16, and then it keeps going, right? Now, this is a geometric series, right? But what we want to do is we want to look at common ratios because that can give us a little bit of insight. Notice that 3 divided by 4 is 3/4. If I take 9 over 4 and divide it by 3, I get 3/4, I claim. See, and if you notice, 9/4 divided by 3 over 1 is 9/4 times 1/3. 3 goes into 9 3 times, and so you get 3/4. So it's probably safe to assume that the common ratio is 3/4, and it will be. Now, what I did is I decided to leave that 4 alone, okay? So in other words, I'm going to write the rest of these terms in closed form. And so I get 4 plus 3 plus, and then I noticed 3 times 3/4 ended up being 9/4. 3 times 3/4 to the second, I claim, is 27 over 16. And if I want the next term, I'm going to take 3 times 3/4 raised to the third. So you notice I'm looking for a plus ar plus ar squared plus ar cubed. That's the pattern I should be looking for. And so once you get your r, and then r in this case was 3/4, then it just turns into figuring out what that pattern is. And so this is what I did on the third line. I get 4 plus the summation from n equal 1 to infinity of 3 times 3/4 to the n minus 1. The absolute value of r is equal to 3/4, which is less than 1. And so that tells me the series converges, and it's a geometric series with the absolute value of r equal to 3/4, which is less than 1. Now, a equals 3 and r equals 3/4. So this sum ended up being 4, so I just kept the 4 there. And then I'm going to add 3 over 1 minus 3/4. So in other words, A is 3, R is 3/4. And I just plug that in. And then when I go to simplify, I claim the answer ends up being 16. And that's essentially how that works. Now, if you want, we could do another one like that. Okay? I was thinking of something like this. So we'll call this example 5. All right? And suppose we don't give it in summation form. You know what I mean? So suppose we had this. Suppose we had 2/5 plus 4 over 25 plus 8 over 125 plus 16 over 625, and we keep going. Okay? Now, what I want to do is I want to look at the common ratio. So if I have 4 over 25 and I divide by 2/5, okay? So this is 4 over 25 times 5 over 2. Now, this is 20 over 50, which is 2/5. Okay? So if we look at the next term, the third term divided by the second term. So in other words, we're going to look at 8 over 125 divided by 4 over 25. So this is 8 over 125 times 25 over 4. And that is indeed 2/5. So it looks like my common ratio is 2/5. That makes sense? So the way I'm thinking about this problem is if I have 2/5 plus 4 over 25 plus 8 over 125, and then I keep going, well, I could write this as 2/5 plus 2/5 times 2/5 to the first plus 2/5 times 2/5 to the second, and then I keep going. Okay? Now, I could write this as the summation from n equal 1 to infinity of 2/5 times 2/5 raised to the n minus 1. Now, the absolute value of r equals 2/5, which is less than 1. This series converges, right? Same idea. And then this is a geometric series with the absolute value of r equal to 2/5, which is less than 1. And so 2/5 plus 4 over 25 plus on and on and on. This sum is 2/5 divided by 1 minus 2/5, right? And then this is 2 divided by 3 when you're all done. That's how that one works. And not everything is going to converge, by the way. I hope that makes sense also. And that's something you want to think about. So, for example, if you look at number 6, suppose we had the summation from n equal 1 to infinity of e to the 2n divided by 6 to the n minus 1, right? Now, we have to manipulate this a little bit. So I have the summation from n equal 1 to infinity of e squared to the n divided by 6 to the n minus 1, right? Is that okay? So this is the summation from n equal 1 to infinity of e squared times e squared to the n minus 1 divided by 6 to the n minus 1. And just one more line. This is the summation from n equal 1 to infinity of e squared times e squared over 6 to the n minus 1. Now, the absolute value of r equals e squared over 6, right? Now, let's check out what that is. So, if I take e and then I raise it to the second power and divide by 6, this is approximately 1.23, and that's bigger than 1, right? So this series diverges. Why does it diverge? Remember, this is a geometric series with the absolute value of r equal to e squared over 6, which is bigger than 1. Okay, that'll do it for this video. And I did 6 examples, and they all related to the geometric series. Okay, thank you.